Okay, this is the January 2022 P1 paper. It's question 7. Going to be a little bit of transformations of graphs and then I think some quadratic inequalities towards the end. You can see down the bottom here that what I've done is already draw out a little preparatory bit there. That's just going to be some explaining how to do the answer to this one. Let's get started then. So it says figure 3 shows part of a curve with the equation fx equals x plus 4, x minus 2, 2x minus 9. Given that the curve with the equation fx minus p passes through the point with coordinates 0, 50, find the value of constant p. So I'm going to do a quick little bit of work first of all. Not going to take too much time. That if it's x plus 4, x minus 2, 2x minus 9, then that's immediately going to give me the value of minus 4 there, which I might need later, 2 and 9 over 2 being where those three equal 0, and so where y equals 0, where fx equals 0. So quickly just put those on my sketch. The next point that I need to work out is going to be 4-point part A here, and it's going to be working out where it intersects with the y-axis. So if I want to work out where it intersects with the y-axis, what I'm going to do for part A there or down here, let's work out what f naught is. So f naught is going to be 0 plus 4 times 0 minus 2 times 0 minus 9, and that all works out to be equal to 72. So f naught is equal to 72 here. That value there is 72, and then they're saying when I do f of x minus p, what does that do? F of x minus p will take this graph and move it down p units, okay? So if f of x minus p moves it down p units and it ends up being at 50 there, f of x minus p means, translation, p units down. So in other words, 72 take away p is going to work out to be the new point 50 there, so p must work out to be equal to 22. So that's part A done. Part B then, get rid of that for the time being. Part B says the curve with the equation f of x plus q. So again, if I've got my curve here, f of x plus q will be a movement, a translation horizontally there. F of x plus q is going to move f of x plus q inside the function is a translation of q units to the left, the opposite of what we would sometimes expect it to be. So what I want is, can I make, going back to my diagram a second, can I make this point, or this point end up, when I move them over, can I have them ending up on the origin? Well, we'll do the two easy ones first of all. If q is equal to 9 over 2, or if q is equal to 2, then q being 9 over 2 would mean that point would end up being on the origin. Q being equal to 2 would mean that point would end up being on the origin. And it can work with the minus 4. You just have to have Q being equal to minus 4, because then that would mean that it would move the other way, it would move to the right there. So those are the three possible values that Q can be, so that a horizontal shift of either 9 over 2 units, just do it, of either 9 over 2 units, that one would end up there, of 2 units, that would end up there, or of minus 4, then that one would end up there, any of those three transformations, a translation to the left or to the right, would end up with Q still ending up going through the origin. So that's part B. Let's label that properly. That's part B there. Difficult to show the examiner what we're doing here. I think I just leave it as what I've got there. There's not a lot of method marks in these, but obviously easier for me to show you on the iPad what we're doing. Part C says find f dash x. So if I go back, fx was equal to x plus 4, x minus 2, 2x minus 9. I can just see I'm running out of space here, so let me just move up some of my answers here. That can go up there, and these three can all be on the same line, can't they? Just to give me a little bit more space. Okay, if I want to find f dash x, then the first thing I have to do is to actually factorize, multiply out the brackets to get what fx is going to be. So fx is going to be, it's up to you the way that you want to do it. I want to make it clear to the examiner what I'm doing. So I'm just going to multiply these two out first of all. I've done this on lots of other videos, so I'm not going to take too long over this. X times 2x is 2x squared. X times 9, or minus 9 is minus 9x. Then minus 2 times 2x is minus 4x. Minus 2 times 9 is 18. That works out to be x plus 4. Just take your time with this, you don't make any silly mistakes with it as we're going through. 2x squared minus 13x plus 18. And now we're multiplying this all by x plus 4. I think the easiest way is to multiply all of it by x first of all, which will give me 2x cubed, 13x squared, 18x there. Then multiply it all by 4. It's going to give me 8x squared, 52x, and what's that, 72 there. And then tidy that up is going to give me 2x cubed. That one's not going to change. The x squareds together there make minus 5x squared. The x's make minus 34x. And the 72 also is not going to be affected. So now I've done that, f dash x is just differentiating that. Multiply by the power, take one off the power. Multiply by the power, take one off the power. And just the 34 in there. So that's f dash x. And then part D says hence find the range of values of x for which the gradient is less than minus 18. So this is a quadratic inequality question. I now, for part D, want f dash x, which is equal to 6x squared minus 10x minus 34. I want that to be less than minus 18. Well, tidy it up and get all the constants onto one side. Minus 16. They do that same old trick that they do a lot here with that quadratic. I can divide everything by 2 here. So that's the same as 3x squared minus 5x minus 8 is less than 0. And if you're doing it properly, call them critical values. Critical values are just solving the quadratic. So 3x squared, sorry, handwriting's getting a bit dodgy there, minus 5x minus 8 equals 0. That's going to factorize to 3x minus 8x plus 1 equals 0, which is going to give me x equals 8 over 3, or x equals minus 1. I now combine that with a quick sketch. That's why I've left a little bit of space on the other side here, is that for this question, I know it's a positive quadratic, so all I found so far are the critical values that I know that this positive quadratic must come below the axis and go back up. This one's minus 1 and this one's 8 over 3. So if I'm now trying to work out when is this less than 0, it's that little bit in there, isn't it? So this time my answer is in between my two critical values, 8 over 3 and minus 1 there. Hopefully that makes sense to you as the answer.